Angles. So you guys have been learning about angles since when? Since what? Third grade? I don't know. When did they tell you about angles? First grade.
Some grade.
Well, I don't know. It's one of those things that you know a lot about already. So let's see how much you know. This is all review stuff. So what's an angle? What's an angle? Rolly, what's an angle? Two rays what? Two rays connected by the same endpoint. There you go. That's what it is. Excellent. How do you name angles? Now, let me just draw a little picture here. So you got two different rays. Now, here's a whole bunch of them. And so you can have multiple angles involved here. But let's see, how do we name them? The first couple of pieces here, the point where they meet that endpoint is called a vertex. Okay? So let's see. You already know. How do you name that thing, Christian?
3 points.
Okay, so what's the name of this angle?
The angle CAB.
Angle CAB. That is one way of naming it. Is you look for one ray, then you give the vertex, then you look for a point on another. Now the angle symbol, it looks like this. I tend to make a little arc on them. You don't have to do that if you don't want to. I do that so that I know it's not a less than. It just makes it a little clearer for me. It's okay if you don't want to put that little arc there. It's also how my wonderful geometry teacher did it, so I just learned how to do it that way. So angle CAB. What's another way of naming this angle? What do you think, Thomas? Just the vertex. So what can we call it? Angle A. Now, you have to be careful though, right? Like if I over here have this angle here and say A, I say angle A. What am I talking about? Am I talking about 3 different angles? I mean, you have to name your angles so that it's unambiguous. Here's our big word for the day. Unambiguous. What does that mean? What does unambiguous mean? Clear. Ambiguous means not clear. Unambiguous means not clear. Clear. So this is ambiguous here. Which A do you think? So when you have it and it's not very clear, you can't just use the single letter name. Okay, how else can I name this thing? Now I'm on stuff. What? Huh? Well, no, what's its name? What's its name? It isn't a cute angle, but what's its name? What another way to name it? BAC. As long as your vertex in the middle, you could start it with that way. That's perfectly fine. Now see this little A in here? So you could put like a little A in here, and we're going to call this angle A. Very often those are lowercase. We can also use Greek letters. So you're going to learn more Greek. A very popular Greek letter name for an angle is theta. A theta kind of looks like this. So you can put a little theta in there. So I can call it angle theta. That's another way of doing it. Let's see if I got them all. Yeah, I think we did okay. Different ways of naming it. Angle theta. Okay, we did that together. What else we got? Classifying angles. So I think you helped me with this one. What kind of angle is this? It's an acute angle. What does that mean? Yeah, how can I tell if it's acute?
It's an angle less than 90 degrees.
It's less than 90, but bigger than?
Bigger than.
Yeah, so if this is my theta, it's bigger than 0, but less than 90 degrees. Now, degrees are actually an important thing to state. Let's just go back for a second here. It's really what's happening when you have angles, is you're really kind of opening up a position here. So if I look at one like this, how far am I opening up this angle? How many degrees? 90 degrees, so what is this?
Right.
It's a right angle where it's 90 degrees, so I'm opening up to 90. What about if I go a little farther here? What's that called? Yeah, it was obtuse. And so what is that? So your theta is going to be what? 90 degrees to 180? All right. What's it called if I go like this? Yeah, that's a straight. That's a decent C, and that's when you are at 180 degrees. Now, if you pass that mark, what is a reflex angle? Reflex. So for some reason, we don't usually like teach that one, but once you pass that 180, you're making this like reflex angle. So that's kind of a new name for it. I have a little angle website here, someplace. This one, here it is. So like here it kind of shows. So acute. We go to right, obtuse, now we're reflex, right? That's what happens. Now, what is the degree measure all the way around? Here it is, 360, right? 360 degrees in a circle. 360 degrees. Why 360? That's kind of a strange number to have 360 degrees. Why don't they make it like 1,000? Or, you know, a nice decimal number, like 360. See, some of us have an answer for that. I want you to think about 360 and what's significant about that number. There's another number kind of like 360 that's pretty common. But you all know, I know you know this number that's kind of like 360. It's a little bit more. Number kind of like 360. Yeah.
It's similar to 365 days in a year.
365 days in a year. So like ancient civilizations were pretty smart in their way. They noticed that for the Earth to go around the sun, their estimation was 360 days. That's pretty good when you think about that they didn't have technology. So that became the norm, 360 degrees. They cut everything up in those kinds of little slices. So that's why we use it to this day. But is there any real meaning to that? You know, maybe not. So when you get into learning about trigonometry, you're going to learn another way to measure the opening of these rays. And they don't use degrees, they use something else called radians. You don't have to worry about that now, but it's not degrees. So if you tell me an angle right now, you tell me the angle measures 45, if you don't say degrees, I think you mean 45 radians, and I know you don't. So please make sure, if you're giving me an angle measure, you say, here's the answer, it's 45. If you mean 45 degrees, tell me degrees, because that will become important when you start learning about that other way to measure angles. All right, what else do we got here? We have measuring angles with a protractor. I'm totally not going to know. Who has measured an angle with a protractor ever? Not everybody has measured. No, why do we measure? So it doesn't make sense for us to spend a lot of time. Here's my quick review, and it'll be amusing because I'm horrible with these little tools. So, right, you take the protractor, you look at the crosshairs, right, it goes right on that vertex, best that you can get it. And then there's two scales here. How do you know which scale to use to measure this angle? Last how do I know which scale to use?
If you start at the one you made, like
I'm here. Yeah.
and then you go around that way, and then you get where this one is counterclockwise. So
Yeah, so which right? Is it 130 or is it 150? Which is it? I'm sorry, 30 or 150. Right, because this scale says 30, this one says 150. Which one is it? Twice 30. But that would be ridiculous, right? Because we have a good feeling what an acute angle looks like. It's going to be less than 90. It can't be 150. Also, we're at 0. When you start here, when both rays are here, we haven't rotated yet, it's 0 degrees. You find 0. Now I'm starting to rotate up, so there's my 30 degrees. And that's basically how you read a protractor. To me, it's probably not worth spending our time with that unless this is a big deal. Because to be honest, we're not going to be using protractor to measure angles. And in fact, we have to be super careful that we don't use protractors. I may give you some question, and I'm going to want to find it. And there's going to be x's, and there's going to be some other x's, and I'm going to have you use facts, properties, theorems that we've learned about to figure this out. It may not be drawn to scale. So you may figure something out, and this angle comes out to 45 degrees. And even though the protractor says it's 30, your answer better say 45 degrees. So don't use a protractor if you have a problem set. You're like, what is the measure of this angle? There's all kinds of x's. You don't know what it is, so you use your protractor. Don't do that, right? Because they're not drawn to scale. Not drawn to scale. Not drawn to scale. Okay? Just thought I'd make that point. Different angle pairs. Now, it used to be this was review, and then people stopped taking like math A. This is where we tend to teach this kind of thing, but maybe you know it anyway. Complementary angles are two angles that add up to 90 degrees. So these angles can be adjacent angles, and this word adjacent means next to. So you can say the library is adjacent to the supermarket. You know, they're next to each other. So these two angles are adjacent. They share a ray, and they're right next to each other. These are non-adjacent angles. They're two separate angles. They're next to each other. Look at them, but they're not sharing a side or a ray there. So both these angles, you add the measure of angle 1 and the measure of angle 2, you get 90. Same if you add the measure of angle 3 and angle 4. And supplementary are when you add up to 180 degrees. Two angles that add up to 180 degrees. Here's what it looks like when you have adjacent angles that are supplementary, and these are some non-adjacent angles that are supplementary. How are you going to remember that complementary is the 91 and that the supplementary is the 181? There's nothing real special about these names here. Are you going to remember that? You've never really thought about it before? Are you going to remember it, Mom?
Supplementary has
What? How does that work? Supplementary has 2 p's, therefore it's 180. And complementary has 1 p, therefore it's 90?
yeah,
This P equals 90 degrees, so 2 P's must equal 180. It's obvious.
All right, as long as you got that. All right, that's one way. It's
Right.
working. Remember it. A very wise teacher at the school told me this. Complementary. All right, you see the word supplementary. It was kind of awesome when she did it. She goes, look the line here. It looks like 90. I was like, really? It does. And then she said, put this little line here, and it looks like an 8 for 180. I thought that was kind of awesome. So if the words themselves don't really give us much clues, so you can do that if you're having trouble remembering them. Now, a linear pair are supplementary angles that are adjacent. This is a linear pair. So if you see a straight line with kind of a ray popping out, these 2 angles are supplementary because this adds up to 180, and they're called a linear pair because they're a pair on a line. And we also have vertical angles. Vertical angles are when 2 lines intersect, they make an X. The opposite angles are called vertical angles. They do not have to be, vertical. These are kind of horizontal looking. So it just means the opposite angles. These ones are also vertical. These are vertical. These are vertical. An important thing about vertical angles are congruent, meaning they have the same measure, right? You knew that?
I was going to say,
360.
is it?
Yes, I know. I got you on the wrong, yeah.
Yeah. So you just like divide
It's 360 all around, but I have to know at least one of them, right?
Yeah, yeah.
If I know one angle, I will be able to figure it out. We're going to look at that in a minute. Yes.
There are not, if there's not 4 angles, but it's still vertical.
How are there not 4 angles?
Like if it were just 3
How do I do that?
and 4 and 5.
Like they're apart? Yeah, then I don't know anything about them, right? But if they're presented as they're not vertical angles if they're apart. They are vertical angles if you have this situation, an X shape, the opposite ones are vertical. I think we're always going to do that if they're vertical. Alrighty, so how does this work? So the basic thing here is we want to find the measure of the angles. Find the variable, find the measures of the angles. Well, what do I know about the measure of this whole thing? Michelle, what do I know? Are they equal? I don't know, but what do I know? This whole thing is, right, these are supplementary angles. Linear pairs are always supplementary. They're always going to add up to 180, so I can take both these measures and add them, and I should get 180. And now it's a matter of just solving this little equation here. So the 19x minus 10 equals 180. Add 10 to both sides using the addition property of equality. Divide by 19, 10. Right, so I get x is 10, and now I can plug in. 7 times 10 minus 3 is 7 minus 3. 67 degrees, putting my degree symbol in. And then this one is going to be 12 times 10 minus 7. 120 minus 7. 113 degrees, right? Don't forget your degrees. And then how can I kind of just do a quick check, little sanity check that this is right? Add them. What should I get? 180. Do I? What's 113 plus 67? That's a 10 carry to 1. Yeah, good. Right? Is it worth taking those? Did that take me less than a second? Pretty much. You can do it in your head. Check it. This one now is a little more interesting, maybe. So I can see the linear pair even though there's something kind of popping out here. So let's ignore this pop out for now. Adds up to 180. What does the little box mean? 90 degrees, right? So what does that mean for this side? Yeah, what does that mean, Rohit? Why? It's supplement. Supplement. Whole thing 180, subtract 90. Fantastic. So what does that say about angle DEG and GEF? What are they adding up to? What do they add up to? 90. So what's the word when two angles add up to 90? Complementary. These two angles are complementary, so I can just set them equal to 90. Then x equals 90. I want to say 9. So let's see, 6 times 9, this one looks like 54 degrees. 4 times 9, 36 degrees. Do they add up to 90? Do that check, because I make mistakes here all the time. I check it. Okay? Look at this one. You have a question? Huh? Well, yeah, look this one. You kind of have to look at them a little bit. I know about linear pairs, and I found one in the same variable. Like here's another linear pair, but they're two different variables. Not going to help me. So I think I'll concentrate on this one. I know that's going to equal 180, right? So 8x plus 26 plus 3x, 180. These are supplementary angles in a linear pair. 11x plus 26 equals 180. All right, so now I have to subtract that 26 from both sides. Equals 154?
Yes.
And now I have to divide both sides by 11. Goodness gracious, what am I going to get here? 14. So 14? It's 13?
Yeah.
I don't think so,
Well,
because
no,
I know
it is.
it's got to be 14, right? Okay, so x is 14. That means that this one is 14 times 3. 42 degrees. And this one is 8 times 14 plus 26. Okay, great. Now I've got two ways now of actually finding this. I can see this linear pair, so I can say that 5y plus 38 plus 42 equals 180, right? Because this whole thing is a linear pair. The other thing I can do, though, is I see an x. I have vertical angles, so this angle and this angle have the same measure. So 5y plus 38 equals 138. Let's do this. This side of the room, from Sarah and Maz this way, yeah? You're going to solve this equation. And Thomas, this way, you're solving this equation. Let's see if we get the same thing. Take a second, solve those equations. Okay, so she got y equals 20. And then what do we have on this side? What do we have on this side? Y equals 20, same thing, see? So you can use either fact, whichever way you see it to get there. We're going to plug the 20 in here, and you should get 138, right? Or, yeah. Okay. Here we go. So, yes, we looked at our angle pairs. So now we've got some postulates. So these postulates kind of are analogous to the ones we did for segments, only they're for angles, which means they're like those ones, kind of. So the protractor postulate is kind of like the ruler postulate. It says that if you know two measures, two degree measures, you can actually figure out the angle measure. Basically says you can use a protractor. So we normally put our protractor one end at 0 and the other end somewhere else. But simply what we're doing is you're subtracting one from the other. If you really wanted to, you could put one ray along the 20-degree line if you wanted to. And the other ray would poke out wherever it pokes, and you would just subtract from it. You could. So it's kind of like the ruler postulate, only says you can use a protractor. But we are not going to be using a protractor all that much. Yeah, Jerry. What? It basically says that if you want to know the degree measure of, say, this angle, you look at this number here, and you look at this number here, and you subtract. And that tells you the degree measure. When we use a protractor, it's always starting at 0. If you really wanted to start at like a different number, like if I put 20 down here, and we move this up 20, and you just subtract, you're going to get the same number. Kind of like the ruler postulate. It's not as useful, perhaps, to us as the other is. Question? Okay, that's the ruler postulate. Okay, quickly.
You see the degree, right? You have to know.
Well, it's just understanding what you're actually doing, right? Okay, so the angle addition postulate, a lot like the segment addition postulate. Remember the segment addition postulate? If you have AC and B is between them, the length of AB plus the length of BC equals the length of AC. So very similar with angles. Now let's just review how you refer to these things, the notation. So angle RST is that physical angle, those two rays that intersect at a common vertex. If you want the degree measure, or just the angle measure, I should say, you put this little m here and you say the measure of angle RST. So this is an angle, and this is a number. It's a lot like, you know, I've got segments AC, and if I don't put the little bar on top, I have the length of AC. So this is the physical angle, and this is its measure. So if I'm looking at this one, so here's RST, right? Angle RST. The measure of that angle RST is the sum of the two angles inside it, or three, or however many you have. But angle, measure of angle RST is the measure of angle RST plus the measure of angle PST. So you add this piece and you add this piece, you get the whole piece. That's all the angle addition postulate says. So looking at an example of the angle addition postulate. So given that the measure of LKN, this whole thing is 145 degrees, we're going to turn pages, right? We're on the top of page 2 here. What are we finding? The measure of LKM. So find this degree measure and find NKN's measure. Find that degree measure. So angle addition postulate says add the two pieces together, you get the whole thing. So this measure is whatever 2x plus 10 degrees is, right? Plus this 4x minus 3 degrees. If you add all that together, you should get 145 degrees. So does this part just make sense? It's a lot like segment addition, just adding two pieces to get the whole. So let's finish that up there. We've got 6x's plus 7. That's going to be 145. So I'm going to subtract the 7 from both sides. So 6x equals 138. I'm going to divide both sides by 6. 138 divided by 23. So I found my x, but that's not what the question is. It wants these measures. So the measure of angle LKM, which equals 2x plus 10, is going to be 2 times 23 plus 10, which is 46 plus 10, which is 56 degrees. So I didn't, you don't necessarily have to put all those degrees in when you're doing all the little computations, but when you're done, you should put the degree measure in. The measure is 56 degrees. The other one is measure of angle MKN equals 4x minus 3. We believe that the x is 23, which is 92 minus 3, which is 89 degrees, right? I got the answer here. So we think this one's 56, and we think that one's 89. What's a really smart check to do? Add them together just to make sure we didn't make a mistake. Let's hope that 56 and 89 equals 145. Yeah, you carry the 1. Yay. Okay, so I'm feeling good that we found the correct measures. Okay, so very similar to what we did with segments, only we're doing it in angles. Question? Okay, angle congruence. I know we've spoken about this. I'm just going to keep saying it because I make sure we're good. Two angles are congruent if they have the same measure. So two angles aren't equal. The angles themselves can be congruent unless they are the same angle. But these are clones of each other. They are congruent. They have the same opening, right? They open up the same amount of degrees here. So you write measure of angle A equals the measure of angle B because these are numbers. They are going to be the same if they have the same measure. Equal makes sense. Angle A and angle B are congruent just says there's two different angles that have the same measure. So we have spoken about that before. So the way we show congruence, now if you remember when we were looking at segments, so if I want to show different things are congruent, I use this little marker. So this one says this side congruent to that side. Well, what if this side was congruent to that side, but not the same as this one? You would put two little markers. So that's kind of how you show different sides are congruent when you're working with segments. When you're working with angles, you make a little arc. So one arc, these are congruent angles. Two arcs, these are congruent angles. These two, L and P, not congruent. So the number of arcs helps you match up the congruent ones. So angle L is congruent to angle M, and angle P congruent to angle N. So get another little notation note. how we mark things on diagrams. You will be marking diagrams. Or then, hopefully that's straightforward. Question?
No, I need to.
No? You're okay? Okay. He's happy. That's okay. An angle bisector, if we remember what a segment bisector did, it cut a segment into two congruent pieces. Well, so does an angle bisector. So I've got, what do I have here? Angle XYZ, that's this one, is bisected by ray YW. When you hear that word bisect, it means two cuts. But more than that, they are two equal cuts. So this piece here will be congruent to that piece there. That's what a bisector does. It makes two congruent angles within the angle you started with. Cuts it in half. So let's see. If we know that the measure of x, y, w is 18 degrees, can we find the measure of the whole thing? Jerry, what do I do here? Help me. Yeah, because what's this one? It's also 18 degrees. So the whole thing will be 36 degrees. Bisectors, you're going to have the same measure to it. Okay? Pretty easy, I hope. All right, so we are up to U tries. Before we go there, I just want to talk a little bit. But that's basically the new stuff that we're learning here.